Piecewise functions are functions that have more than one piece, or they're defined by more than one rule. So here we say functions that are defined by a rule that has more than one piece, okay? The absolute value function can be defined by a rule that has two different pieces. Because if I want to know what the absolute value is, well, if x is greater than or equal to 0, then it's just going to be whatever x is, right? If x is 5, then it's 5, so on. But if x is negative 5, well, if I put a negative 5 in for x here, then what's really happening is I'm saying a negative of my negative because it's always going to be positive. So that's why it's saying there's two different pieces. If x is great, so we read it like this. Here's my y value. If x is greater than or equal to 0, I say it's whatever x was. But if x is less than 0, then I say it's the negative of whatever x was. So let's do an example. So 1, as we can see from here, 1 is going to be the dividing point of these two pieces, right? So I want to know, for example, when x is 1, which one of these am I choosing? Well, I'm going to have to choose this because this is including 1 and this is not including 1. So if I want to know what y is when x equals 1, I have to look at this bottom function. So the function I use is 1 minus x. And so I plug in 1 and I get y is 0. So I have a point when x equals 1, y equals 0. When x equals 2, I still use 1 minus x. So when x equals 2, I get negative 1. So there's my other point. And this is a linear function because this is the same as minus x plus 1, right? And I have a slope of negative 1, which it looks like I'm going to have a slope of negative 1 because I am going down from here to here. And it continues on because it's when x is greater than, so it just goes on forever in that direction. But what if I say x is less than 1? So let's say x is equal to 0. Now I have to use this function because 0 is less than 1. So now I'm using x squared, which is again 0. So when x equals 0, I have this point 0, 0, right? When x equals negative 1, let's see what happens. So when x equals negative 1, again, I'm using x squared, and negative 1 squared is 1. So when x equals negative 1, y equals 1. So I have this point. Let's say when it's negative 2, it's going to be 4, right? Because we're going to use x squared. So this is 4. So 1, 2, 3, 4. So it's kind of going to go like this, okay? The only problem is I don't know what's happening between 0 and 1 because I've just picked whole numbers, right? So what I want to do is I want to pick 1 again because that's the transition point, right? It's doing something when it's greater than or equal to 1. It's doing something when it's less than 1. So I need to go all the way to 1. And this time I'm going to plug it into x squared. And when I do, I see that it's going to equal 1. So I have this point at 1, but it's not a closed circle, is it? It's going to be an open circle because it doesn't include the value at 1. But now I know this graph, it continues up like this till it gets to 1, and then we have an open circle there because it doesn't include 1. Okay, so I do need to figure out what it would be if it included 1, but then I make it an open circle. And oh, look, there's a much prettier picture of exactly what we just did. So if I look at what we graphed, and it looks very much like this, except this one is, of course, much prettier. Now let's find the rule that describes the following piecewise function. So let's put our graph up. And we have 3 different transition points, right? We have x is greater than 1. So let's put a 1 here because we really need to know what's happening around 1 because it's changing. And then this is between -2 and 1. So let's go -1, -2. And the top one goes between -2 and -3. It doesn't continue into negative infinity because I don't have anything defined at -4 or -5, right? So we don't go past -3. Let's start at the top. So let's pick a number. Let's pick both -2 and -3. Even though they're going to be open circles, I really want to know what those values are. So when x equals -3, I'm going to use the top function because I need to know what's happening. And that would be -3 times -3, which is +9 minus 6. So I get a +3. So 1, 2, 3, which means at -3, I get +3, but it's an open circle because it does not include -3. And then -2, I know if I wanted to find exactly what it is, then I would have to go to the middle. But I want to know what happens when the top function is -2. So I plug it in, I get 6 minus 6, and I get 0. The other end is at -2, 0. And also we can see it's linear because we can see the function is -3x minus 6, which is a linear function. So that means it's just a line that connects those 2 points. Okay, and they're both open circles at the end. And these are from the top equation. Okay, I'll do them all in different colors. Then we have the middle part, right? Which is 2. And that does include -2. So when x equals, so this is for the middle, when x equals between -2 and 1, including both endpoints, my y value is 2. So at -2, at -1, at 0, and at 1, all my values are 2 because I just used 2 for y. So between there and 1, and again, because it's less than or equal sign, I include those points, and this is just a constant function, just a straight up cross line, okay? And then the last thing I do, now we're talking about when x is greater than 1, but I still want to see what number it would be if I plugged 1 in. And I plug 1 in and I get -1 plus 2 is 1. So I know that that next one is actually going to start here at 1. When x is 1, y is 1, but it's open at 1. And it's got a slope of -1 and a y-intercept of 2. So we know that it's going to be sloping down. So let's put in x is 2. When x is 2, y is 0. And it's going on forever, right? It's not telling me an endpoint. So I'm just going to connect these 2 lines, and this is going to go on forever. And that's how we graph a piecewise function. I think the next slide has a prettier graph, which looks like our graph, right? So this is exactly how you plot piecewise functions. If I asked you to tell me what is y when x equals -2, well, when x equals -2, well, I don't use this one because that doesn't include -2. And I don't use this one because x is not -2. I have to use this one when x is -2 because this middle one includes -2. So my answer would be 2. Right, have a good day.